I'm going to talk to you about absolute extrema. We've already kind of talked about the fact that absolute extrema is the max and the min on the whole entire graph. But as far as looking at an equation, we need to look at that. So basically what we're going to be finding is the actual max and the actual min on the whole entire graph. We're going to have to look at the y values this time because we need to know how high and how low it actually goes. On these problems, they have endpoints, and because they have endpoints, that means there will be a min and a max that's highest and lowest. When there's not endpoints, like some of the problems that we've been doing, there may be a max and a min, but there's not always both because the graph might continue up or down. But the problems we're looking at right now, they have endpoints, and so we're just looking in the interval that's given from end to end. So let's look at this example. Alright, first thing we're going to do is we're going to find the derivative because the derivative is going to give us all the possible maxes and mins. Also, I should have given you the interval that's for this particular problem. You'll be given an interval and you'll be given an equation, and we want to find the absolute max and min on that interval. When we find the derivative and set it equal to 0, we go ahead and solve it, factor out what's in common, and solve. So we get x equals 0 and x equals 1. So in the interval from -1 to 2, the only possible mins and maxes are x equals 1. Now our endpoints are also included because depending on what the graph looks like, and I'm going to just draw a quick sketch to indicate, but like if the graph looks like this, there's a max there and a min there. But if these are the endpoints, there's a possible min and max there as well. So we found our possible ones in between, and then we also have to consider our endpoints. So what we do once we find all of those is we put them on a t-chart with x's and y's. So we have -1, 2, 0, and 1. And then what we do is we plug those values into the original equation to find the original y values. So I want to figure out, okay, what's the y values at each of those places? I'm just going to go ahead and tell you that the y values would be 7, 0, -1, and +16. Well, if those are the y values and the x's are the only possible places of the mins and the maxes, what that tells me is that our min is -1 and our max is 16. And here we're talking about the absolute one. We're talking about over the entire graph, our absolute min would be -1, and over the entire graph, our absolute max would be 16. Now, I still don't know at -1 and 2 what's going on, but we can use the process where we make a sign chart and indicate whether it's a max or a min. But because we're just looking for the absolute one, we can just look at those endpoints. Okay, let's look at another example. Alright, first thing we're going to do is we're going to find the derivative. We're going to set that equal to 0. Divide. And take the cube root. When you take the square root, that's when we do plus or minus, but when we take cube root, it's just +1 because the -1 would not work. So in our x and y chart that we're going to make, we're going to use all of our possible values that we get. When we make the t-chart, you have to put the endpoints and you have to put the value we get, but you have to put all critical points. So I notice this should be a negative right here. We do have to figure out that If you rewrote that, see, x can't be 0. So 0 is also a critical point, so you should use all of those values. Alright, you're going to plug all of those values into the original equation. You get -5, 0, -1, and -0.24. And what we find out is that -5 is the absolute min. That's the lowest it could go. And our absolute max is our biggest value, which is 0. And the problems you'll see are very, very similar.